I'm going to show you 90 lines of Python code which solve it in 3 seconds using a pruning technique. Let's dive in. We are given a two-dimensional square grid containing empty space, dot, mirrors, slash and backslash, and splinters, pipe and dash. The beam enters in the top left corner from the left and heads to the right. Then its behavior depends on what it encounters as it moves. If the beam encounters empty space, dot, it continues in the same direction. If the beam encounters a mirror, slash or backslash, the beam is reflected 90 degrees depending on the angle of the mirror. For instance, a right-moving beam that encounters a slash mirror would continue upward in the mirror's column, while a rightward moving beam that encounters a backslash mirror would continue downward from the mirror's column. If the beam encounters the pointy end of a splitter, pipe, or a dash, the beam passes through the splitter as if the splitter were empty space. For instance, a right-moving beam that encounters a dash splitter would continue in the same direction. If the beam encounters the flat side of the splitter, the beam is split into two beams going in each of the two directions the splitter pointy ends are pointing. For instance, a rightward moving beam that encounters a pipe splitter would split into two beams, one that continues upward from the splitter's column and one that continues downward from the splitter's column. Beams do not interact with other beams. A tile can have many beams passing through it at the same time. A tile is energized if that tile has at least one beam pass through it, reflect in it, or split in it. With the beam starting in the top left, heading right, how many tiles end up being energized? First, I define 4 directions in which the beam can move, as a change of x coordinate and y coordinate. Then I do the heavy lifting and define possible beam movements and splits given the shape of the tile we are at and the direction the beam is coming from. For example, if the beam encounters empty space from the right, the beam is continuing to the right. That is making my code as simple and as readable as possible. The algorithm itself is simple. I have a list of beams containing the beam starting in the top left heading right. In a loop, I remove the beam from the list and move one step in the direction it is heading. If the beam escapes the tile grid, I process the next beam. If the beam encounters the same tile in the direction it has already passed, I prune this beam and I process the next beam. Then I note that at a certain position xy, I energize this tile with the beam heading in the current direction. Finally, I move or split the beam given the move's logic. I add those beams to the list of beams I have to process. At the end, I simply print the number of energized tiles. The twist for the second part is that the beam could start on any tile in the top row, heading downward, any tile in the bottom row, heading upward, any tile in the leftmost column, heading right, or any tile in the rightmost column, heading left. To produce lava, you need to find the configuration that energizes as many tiles as possible. I completely reuse the code from the first part. The only difference is that I try all the possible starting beams and keep the maximum. It is probably not the fastest way, in terms of computational time, to solve this problem, but it is arguably the fastest way to solve part 2 in the contest environment. It is also the most readable one. If you like this video and would like to see more like it, please subscribe. Thank you.